welcome back yet to another video. Today we're going to focus on integration and introduction to integration. Just to point out that I am zooming in on only the CXC's integrated maths syllabus, so I'm not going to touch base with every aspect of integration. All right, but it's a basic concept, and let us see how it works out. All right, so essentially we can consider integration as the reverse of differentiation. All right, and you know, when we're doing differentiation, for example, if we want to find a gradient of a point on a curve, what we'll do is to differentiate the curve function, and when we differentiate it, we actually get what we call a gradient function. All right, and since we're talking about integration and we say it's the reverse of differentiation, we should be able to integrate the gradient function to get back the original curve. All right, so in essence, that is what integration is all about. All right, now the notation or the symbol that we use is different from differentiation. All right, when we're integrating, we use this symbol here. It's like a seahorse, right? So it's like that. As you can see, it's right here, but it's not done properly. It almost looks like an F. All right, I must apologize about that. Here's another one, and that's the integral sign. All right, so as I was saying earlier on, that if we differentiate, we're focusing on this statement up here, this statement here. If we differentiate a curve function or any function, we'll get f prime. Okay, I don't think that should be there. So if we differentiate f of x, we get f1 or f prime of x. Now, as I was saying, if we integrate f prime x or the gradient function, we're supposed to get back the original function. And notice what we have, something called plus c, where c is a constant of proportionality or proportion. All right. Now, how do we read a statement like this? This is how we read it. The integral of 3x plus 2 with respect to x is, that's the answer. All right, now later on I'll show you how we get those answers. All right, this is just saying that x is a real number and x can't be 0. All right, so let's move on to the next slide. All right, so this is just a little useful bit of information about certain properties of integration that we can use. So what this is saying, if f and gx are two composite functions, and we have something like this, so a is a constant, what we can pull out the constant one side and just work on the function. All right, second part, if we have a composite function, all right, meaning more than one terms are together, we can separate each term and integrate them differently or independently. That's a better word. All right, okay, so let's look at some notes here or some useful information. All right, so this is the part where I will teach you how to actually integrate. All right, and I will start with this. So on the left column here we have the functions, and on the right column here we have the integral of f of x. So see, this is how I want the symbol to look. It should be a bit longer than the function. All right, so what this is saying for the first row is that a, let's say a is say 7. All right. Now, when we integrate 7 with respect to x, according to this thing here, we'll just end up going to be getting 7x plus c. All right. So when we integrate a number, all what happens is that whatever we're integrating with respect to the variable, you just add on it to the number. Likewise, if I ask you to differentiate 7x, what would you get? 7. All right. So do you see the reverse situation here? All right. And notice we have plus c. All right. So for all of them, when we integrate, we always end up with plus c. All right. Let's look at x. What happens when we integrate x? When we integrate x, we get this. Well, let me explain. So this part is very important. So when we integrate x, now x is actually the power of 1. Alright? So when we're integrating, all we need to do is add 1 to the power. Alright? And whatever sum we get, we reciprocate that sum and multiply it by the original term. Alright? So 1 plus 1 is 2, so we're going to reciprocate 2, which is a half. And we write back x to the half plus c. And that's how we integrate a term. Let's look at x squared. When we integrate x squared, by the way, I should have always have this thing here. That's what that's proper setting up. What I'm gonna do, I'm gonna add 1 to the power, which is 3. Alright, and then if I reciprocate 3, what do I get? 1/3, and then I write back x to the third plus c. Alright, likewise with x4. Sorry, not x4, x cubed. When you integrate x cubed, you get what? 3 plus 1 is 4. Reciprocate 4, you get a quarter. X to the 4th power plus c. And here we have a little generalization or formula of what we were just doing a while ago. And that's how you integrate expressions or terms. Alright, now you have some special cases like trig functions. Alright? So when we integrate trig functions and when we differentiate trig functions, this is a bit different, right? So you probably know that if you differentiate sine, you will get cos. Alright? And if you integrate cos, you're going to get back sine. Alright, so look at it. When we differentiate sine, what do we get? We get cos. But if I integrate cos, I get back sine. Yeah. If you integrate cos, what do you get back? Sine. Alright? And when we differentiate cos, we get negative sine. But when we integrate sine, we get negative cos. See there? Integrate sine, we get negative cos. Alright, what about when we have like a number, like for example sine, say 5x? What happens if you have sine 5x and we integrate that? So what's going to happen is that we're going to differentiate that expression here, which is 5, and then we reciprocate that 5 to give you 1/5. Alright, I know when we integrate sine, we get negative, so it's negative cos 5x plus c. Oops, that should be a 5. Alright. Now you have others like e to the x, 1/x, and so more. Alright, so as we go along, I will explain them to you. But this table here, guys, is like your Bible or guide to integration. Alright, let's look at some questions. Alright, so what we're going to do is that we're going to split up each term and integrate each term individually. So we have x to the 4, so that's going to be 1/5 x to the fifth. But here we're gonna have well, if we ignore the negative 7 and we just look at the x squared, we would have gotten 1/3 x cubed. But because we have negative 7, it's going to be negative 7 times 1/3, which is negative 7 over 3 x to the third power. Alright, so the last one's a little tricky, but let me just see if I can explain it a little bit. So ignore the plus 2 and just focus on the x to the negative 3. Let's integrate x to the negative 3. So we have x to the negative 3. So we're going to add 1, and whatever number we get for the answer, we're going to reciprocate it. So negative 3 plus 1 is what? Negative 2. So we're going to reciprocate negative 2 to get negative a half. Then we're going to have x to the negative 2. Alright? But remember that we have a 2 here. So let's times everything by the 2. Alright, and 2 times negative a half is just negative 1 x to the minus 2. It turns out to be negative 1 over x squared. So there we have it, guys. Alright, let me just drop in we have negative 1 over x squared plus c. Alright? So this is our final answer. Okay, moving on to the next question. Alright, so for this question, what we're going to do, we're going to simplify this, because we're unable to integrate that as it is at this stage. Alright, so we have x to the 4. We're going to divide everything by x squared plus x to the 6 over x squared minus 2 over x squared. Let's simplify this now. So you know, when we divide on the same base, we subtract the index. So 2 from 4 gives us 2. So we have x squared. Let me write that properly. Plus 2 from 6 is 4, so it's going to be x to the 4. Well, with this one, we're going to bring x squared upstairs. So it will be negative 2x to the negative 2. Alright, and this is what we're going to integrate, and not this thing here. Alright. Alright, so let us continue. Right, so we're gonna integrate this instead. X squared plus x to the 4th power subtract 2x to the negative 2 dx. Alright, oops. Alright, so this will go there. Alright, now, as you notice that we didn't actually simplify this, we just bring the x2 upstairs. So let's integrate this. Alright, so if we integrate x squared, we're gonna get a third x to the 3rd power, and this is the other one's gonna be 1/5 x to the 5th. The other one, well, you know, yet again, let us just take out this part and just focus on x to the negative 2. So let us put this one side. So if we integrate x to the negative 2, it's going to be negative 2 plus 1. Alright, and negative 2 plus 1 is actually negative 1. Alright, and then we're going to divide everything by that, which is negative 1. And if we're going to reciprocate negative 1, we still get negative 1. So this is x will be negative 1, x will be negative 1. But remember, we have a negative 2 there. So times it by negative 2. Well, we're going to get a positive, not true? A positive. If we integrate just sine x by itself, we get negative cos x. Alright, so if you integrate sine x, you get negative cos x. But the negative here and this negative will give us a positive. And the 4 is unchanged. So the answer is just 4 cos x plus c. Alright, moving on. Alright, so yet again, if we integrate cos x, so basically, let's go back to the formula sheet, is actually one of these, right? The one with the ax, cos ax. Alright. Oh, notice that pi is just a number, not true? Right. So I mean, if we differentiate all of this, what we get is just negative 3, because this is a number, and that will give us 0. And if we differentiate negative 3x, we won't get negative 3. All right. So hence the answer is just, well, it's going to be a positive. All right, let's go back. If you integrate cos, oh sorry, it's not a negative. Oh, if you integrate cos, it's just sine. So as I said before, what we do, we differentiate this expression here, we get negative 3, but we're going to reciprocate that, so it's going to be negative 1/3 sine, and you write back everything inside the bracket, pi minus 3x plus c. Alright, so that was pretty straightforward. Alright, so okay. So now we have something like this. And what we're going to do is that we're going to rewrite this question. We're going to pull out the 7. So we're going to have 7 integral 1 over x to dx. Alright? And if you guys were to look back on the formula sheet, if you integrate 1 over x, see down here, so there, what we get? We get ln x. And this thing here is just the modulus of x, meaning that is always a positive term. Alright? So if you integrate 1 over x, what do we get? ln x. Alright, so trying to see. I think there's a little mistake here. I don't think they should be here. All right. There's one identity that's missing. I don't think I mixed it up. But I'm gonna show you what to do. But if we integrate 1 over x, what do we get? We just get what? ln x. All right. So let's go back to the question. Right. So what we'll do, we'll pull out the 7 and we just have the 1 over x. So if you integrate 1 over x, we get ln x. So the answer is just going to be 7 ln x plus c. All right. But we can actually go further, you know, because you know what? So this is one answer. And we could go a step further. We're gonna change the constant to ln a. We're just gonna call it ln a. So, all right. So we just change the constant to ln a, and using the rules of logs, we end up with ln a x squared. And by the way, this would be a modulus, meaning that everything is positive. So moving on to the next question. Okay, so I think for this question here, the other identity that was missing was this. I was gonna write it right here. We have the integral of 1 over ax plus b dx is equal to 1 over a ln ax plus b plus c. All right. So basically, if you have 1 over this expression here, what we'll do is going to differentiate that term and reciprocate it. Then you write back ln of that function. So the answer for this will be just 1 over 5. Because if we differentiate 5x minus 3, we're going to get 5. Reciprocate the 5, we get 1 over 5. ln 5x minus 3 plus c. All right. Or we can convert this c here to ln, and we'll end up with ln a 5x minus 3 to the 1/5 power, and all of that should be positive. All right. All right, next question. All right, so if you look, we're gonna go back to the table as it goes right here, that if we integrate e to the x by itself, we get back e to the x. All right, and if you remember that when we differentiate e to the x, we get back e to the x. Right. However, if we integrate e to, say, a function, simple linear function ax plus b, what happens is that we differentiate the ax plus b, and when we differentiate it, we reciprocate that value and write back e to the function plus c. All right, so for this one, what we're gonna do is that I'm gonna pull out the 12 and just have e to the negative 3x. All right, so I'm just going to integrate this. So we're going to differentiate the negative 3x. If we differentiate negative 3x, what do we get? We get negative 3. And so we're going to reciprocate that. So it's going to be negative 1/3 e to the negative 3x plus c. But remember, we have the 12 in true, so we're just going to multiply that by 12. So 3 into 12 goes 4. And 4 times negative 1 is just negative 4. So the answer is just negative 4 e to the negative 3x. Alright, so the answer is going to be minus 4 e to the negative 3x plus c. Alright, and what you can do, we can rewrite this, because we can rewrite this as negative 4 e to the positive 3x plus c. So what will bring down the negative 3x becomes a positive 3x. Alright, so any one of these answers will work, but it's best to know both. Alright. Alright, so let's move on to another question. Alright, so this one's very similar to what we did before. Alright, so what we're gonna separate, we're gonna take out the constant. So we have a quarter integral e negative 16x plus 5 dx. So as I said before, what we're going to do is that we're going to differentiate this function there, and we're going to reciprocate the answer. So if we differentiate that, we're going to get just negative 16, because if we differentiate 5, we get 0. If we differentiate negative 16x, we just get negative 16. So we're going to reciprocate that. So let me just write the quarter there. All right, so it's been negative 1 over 16. And we have e negative 16x plus 5. And we just multiply these two numbers. So the answer is just negative 1 over 64 e to the negative 16x plus 5 plus c. That's our answer. I'd just like to recall that if we are differentiating, let's say we're differentiating this function here, not integrating, what we'll do is that we'll just differentiate this, and the answer we get, we'll just put it beside the e function, times it by a quarter. But when you're integrating e function, we differentiate this function, and then we reciprocate that answer. All right. Okay. All right. Moving on. All right. So what we have here, you notice that this one's a bit different. We have what we call definite integrals or finite integrals. So when you have integrals and with no numbers there, it means that it goes on indefinitely. But here we have some limits. We call this for the upper limit and 2 the lower limit. All right, so this is what we're going to do. We're just going to integrate this function here. And when we integrate that function here, get, well, we have 3. All right, so 2 plus 1, and that's 3, and we put that over 3, and we integrate 2, we get what? 2x. So what we get is actually, let me go up here. It's actually x cubed plus 2x. All right, plus c. So what we're going to do now is that we're going to replace x with 4. All right, so it's going to be in some space. So I'm going to replace x with 4. So you're going to have 4 cubed plus 2 times 4. And then now, what I'm going to do is that I'm going to subtract the lower limit. So this is the lower limit. Subtract the lower limit from the upper limit. So I'm going to replace 2 now in the answer. So it'll be 2 cube plus 2 times 2. And we'll just simply work that out. I'm just taking out my calculator here. So 4 to the third power is 64. And 64 plus 8 is what? 72. All right, subtract. Now 2 to the third power is 8. And 8 plus 4 is 12. All right. And 12 from 72 is 60. So our answer there is 60. So when we have definite integrals, we get a numeric answer. All right. Moving on to the next question. All right, so we have another definite integrals or finite integrals. Let me see if we can quickly do this one. So the first thing we do, we integrate it first. So, oh, by the way, this one is very similar. Very similar, true. Yeah, very, very similar. So if we integrate 3x squared, the 2 plus 1 will give us 3, reciprocate the 3, and the 3 will cancel there. So we'll just get x cubed, subtract 6x. Then we input those values. All right, so it's going to be 2 to the third, subtract 6 times 2. All right, now we must be very careful about the other one. Sometimes some students say, well, you know, sir, a 0, so everything cancels out. They're very careful, right? Sometimes it works, sometimes it doesn't. So it's going to be 0 to the third power, subtract 6 times 0. Now 2 to the third is actually what? 8. 6 2s is 12. 0 to the 3 is 0. That will go away. 6 times 0 is 0. So that's just 0. So the answer, well, this we'll just have to work this out, and that's going to give us negative 4. So that's our answer. All right. So moving on nicely. All right, so this one takes a lot more effort. Let us see if we can expedite this quickly. So we're going to integrate this. That's going to be a third x cubed plus 7 over 2 x squared minus 3x plus c. All right. And then we're going to replace all those values there with what? 9. Alright, so we had more space. So let me see if I can squeeze at the top here. So we're going to have a third, 9 to the third power, plus 7 over 2, 9 squared, plus 3 times 9. Then now we're going to subtract that now. Inputting 3 in the same expressions, we have a third, we have 3 cubed plus 7 over 2, 3 squared, subtract 3 times 3. Alright, okay, so this looks real messy. So now 9 to the third, let's go over here. 9 to the third power, or 9 times 9 times 9 is 729. So 729 times 1/3, or you just divide it by 3, gives you 243. Alright, so we have, but this piece here, so is what? 243. So I'm working out the first bracket. So 9 squared is what? 81. Alright? Alright? And 7 over 2 times 81. By the way, 7 over 2 is actually 3.5. So 3.5 times 81 is 283.5. So this is plus 283.5. Subtract 3 9s, 27. Alright? Now when we work out that, 243 plus 28, 283.5, 27, that's 499.5. So all of this is 499.5. Alright, so what we do, we're going to go over here. So now on the right hand side and work out this. Alright, now 3 to the 3 is 27, and a third times 27 is 9. 3 squared is 9. 3.5 times 9 is 31.5. 3 3 is just 9. Alright, now 9 subtract 9 gives us what? 31.5. Alright, so everything on this right hand here is 31.5. So we're going to subtract 499.5, subtract 31.5. Alright, and that will give us our answer. Answer is 468. Right. So, all right, let's look at this question here. Okay, I think after this question is our last question. So, it says a firm's marginal profit in thousands of dollars is given by a function p, which is defined by p prime x negative 0.8x plus 6. If p 0.5 equals 8, then what is px? Alright, so let us examine this. First things first. You guys realize that that this is p prime. That means that this is a differentiated answer. Alright? So, and they want us to find p. Alright? So remember, you know, from p to p prime we have to differentiate it, not true? But now they give us p prime and we want to go to the original thing. So we're going to have to what? We're going to have to, yes, you're correct. We're going to have to integrate p prime. Alright, so we're going to integrate p prime. So we're going to have to integrate this term here. Alright, so let's integrate it. So we're going to have, remember this. Alright, let me just write this right here. So it's 0.8 x. So remember, x is the power of 1. So 1 plus 1 is 2. Alright, so 1 plus 1 is 2, and then we're gonna have negative 0.8 x squared all over 2. Alright, so let's simplify that. So this will give us so p of x will give us negative 0.4 x squared plus 6x, because if we integrate 6, we're going to get 6x plus c. Alright, so but guess what? We need to find c. Alright? Yeah, we need to find c. How do we find c? They give us additional information. Well, what they said? They said p 0.5 equal 8. What does that mean? It means that if I replace x with 0.5 in p, it must equal to what? 8. If we do that, the only unknown variable there will be c. Hence, we can find c. Alright? Alright, so that's what we're going to do. So we have, let's replace x with 0.5. So it's negative 0.4, 0.5 square plus 6 times 0.5 plus c, and that should be equal to what? 8. All right, so what we need to do is to work out this little piece here. All right, so 0.5 square is 0.25. 0.25 times negative 0.4 is negative 0.1. All right, and so all of this right here, so is negative 0.1. Now 6 times a half is 3 plus c is equal to 8. All right, so let's work this out. I think probably what I'll probably do is just to bring over or subtract 3 from both sides. All right, so you'll end up with negative 0.1 plus c equals 8 subtract 3, which is equal to what? 5. And what I'll do that, I'll add 0.1 to both sides. So if I add 0.1 to both sides, all right, this will go away. So C is actually equal to 5 plus 0.1, which is 5.1. Alright? So, guys, our answer there now. So you see, we just work out the value of C. So we don't write plus C, we actually write in the actual value, which is 5.1. And this, ladies and gentlemen, right here, so what I'm circling, would have been our answer. Alright. Alright, our last question. Alright, so it says the gradient at any point xy on a curve is given by this function here. Given that the curve passes through the point 2, -1, determine the equation of the curve. Alright, so what we're going to do is that we're going to integrate this this function. Alright, as you recall in the first part of this video, I was telling you guys that if you're given a function, right, and you differentiate the function, what you get is what we call the gradient function of the curve. And we can use a gradient function to find the gradient at any point that is on the curve. However, if you're given the gradient function and the points and you ask to find the original equation, we'd have to integrate it. Alright? So this question, the 4x cubed plus 5 is a gradient function. Alright? So we're going to have to integrate that. So we're going to integrate that as 4x cubed plus 5 dx. Alright, so if you integrate that, so 3 plus 1 is 4, reciprocate the 4, we get 1 over 4. 4 times a quarter is just 1. So it's just x to the 4 plus 5x plus c. Alright, so this would have been the original formula or function of the curve. Alright, but we have a problem here. This is we have a plus c, not true. Alright, so it would have been y equal x to the 4 plus 5x plus c. Alright, so, and bonus, they give you a point. Alright, so y there is -1. So what we're going to do is that we're going to replace x and y with those values, and all that remains would have been c. And that's how we're going to find c. When we find the c, we put it back in the expression x4 plus 5x. So y is -1. So we have -1 equal to the 4th power for x plus 5 times 2 plus c. Alright, so we have -1 equals, now 2 to the 4, 2 to the 4 is 16. Alright, and 16 plus 5 to 10, 16 plus 10 is 26. So we have -1 equals 26 plus c. Alright, so with this 26, I'm just going to bring it over, it becomes -26. So c is actually -27. Alright, so the answer, so you said we just worked out c a while ago, you know. So I'm just going to drop in what value of c is. As soon as I get the marker up. So it's plus, it wouldn't be plus, well, it's plus c, but we have a negative here, so a plus and a minus, it gives us a minus, so it's -27. So that's our answer. y is equal to x to the fourth power plus 5x minus 27. Alright guys, so this is the end of the show, end of the program. Just to remind you guys that there are other topics in integration, as we have other aspects of integration, like revolution on the x-axis, on the y-axis. We have integration by substitution, and even if you're doing pure math, it goes further up. All right, guys. So this is just a basic introduction to integration. All right. So I'll see you around. Keep safe. Keep on praying. Never stop praying. And all the best. Take it easy.